Hey Algebra 2, and welcome back to another lesson. It's Mr. Lambright again. Today we're going to be talking about lesson 2.1, all about functions, domain, and range. That's right, we're going to start graphing in this chapter. So, without any further ado, let's get started. Hey, just a quick reminder, if you are virtual only, you need a notebook, and if you are in school, then you should have been given the notes. So, today we're going to talk about domain and range. And functions. Functions are these relations where every x value is only used once. Y values can repeat, but every x value is only used once. We're going to see what that looks like here in a minute. And then we also have domain and range. So for every function, it has a domain, which is all of the x values that are covered, and the range is all of the y values that are covered. So sometimes we have a problem like this, which is just a series of points. The domain, in this case, is a list of all of the x values. So domain is x equals. And in this case, if we put them in order, -6, 1, 3, and 8. The range is a list of all of the y values, and in order, y equals -4, 2, 7, and 14. And that's it. That's what domain and range are about when you just have a series of points. So in this example, we're checking to see if it's a function, seeing if each x value is only used once, and it tells us, nope, 3 is used twice for both 1 and -1. We are going to list the domain. X equals, and in order that would be 0, 2, 3, 4. We do not list that 3 twice because technically it's covered when you list it once. And then range, y equals -11, -1, 1, only once, and 6. For this next problem, we're just trying to figure out if this is a function or not. So what we can do with a graph is we can do this thing called the vertical line test. And what we do, we've got this, this line they've graphed, y equals 3x plus 4. And then what we'll do is we check it with these vertical lines and see if there's any point the orange lines, each orange line would cross the blue line more than one time. And you see how each one of those points hits the blue line at only one point. If it only hits at one point every time you draw a line through it, then yes, this is a function. Let's get some definitions out of the way real quick. A function, as you saw earlier, is a relation where each x value is only used once. The x value could be used not at all, but each x value is used at most once. Examples like that would be a parabola, y equals x squared. Y equals mx plus b. Vertical lines would not count, but that's why we don't list it as an example. Domain is all possible x values in a relation. And the range is all possible y values. Pause now if you need to finish writing that down. We are going to move really fast, by the way, through these examples because there's a lot of examples to get through. But please, please, please stop. I'm going to try to explain every single thing as we go through. So let's start with this list of points. The domain is all of the x values, and we're going to put them in order. So from least to greatest, -1, 2, 3, and 7. And then for the range, we're going to have the y values. That would be -2, 4, 6, 14. Then we are going to graph the points. So we have right 2 up 4. So now we want to graph the points. Let's start with 2, 4. Right 2 up 4. We'll do right 3 up 6. We'll go left 1 down 2. And right 7 up, 14. So I am going to make some points up here. Right 7, 3, 6, 7, all the way up here. I should have gone by 2s, but this works out fine too. And now we're going to do the vertical line test. So we're going to draw these vertical lines and see if we ever hit more than 1 point on the graph. And the answer is that it is a function. It passes the vertical line test. So it is a function. Now we're going to ask ourselves if this graph is a function. This is a parabola. We can tell by the x squared. We're going to make an xy table. And I usually will start somewhere around 0. Plug that in. We get 1 out. By the way, I would strongly recommend doing this in your graphing calculator. There should be information about how to graph things in your graphing calculator here in Canvas. We do -1, we get out 2. +1, we get out 2. Plug in 2 for x, we get 5. -2 for x, we get out 5. 3, we should get out 10. -3, we should get out 10. And then I would strongly recommend pausing and graphing these points. Okay, so we are going to do this vertical line test. And we're drawing, hits once, drawing, hits once. And we keep going. Nope, it only hits once every time we draw a vertical line. So, yes, this is a function. Okay, so we have a bunch of example problems here, and let's try them out. Remember that in a list of points, the best way to determine if a relation is a function is if the x values repeat or not. So let's try this out. On number 1, do we have any repeating x values? Yes, we do. We've got 3 repeating. No, it's not a function. We have repeating x values. And then we look at number 2, and we look at it. Do we have any repeating x values? No, we don't. So yes, this is a function. And remember, you can pause at any time to catch up. Now we're looking at number 3, and we're asking ourselves again, are there repeating x values? And there are. So no repeating x values. That's the reason this is not a function. Number 4 looks way different. We haven't talked about mapping yet. When we have mapping, let's just look at number 4 as an example. It says -2 maps to 5, so we have the point -2, 5. 0 maps to 4, the point 0, 4. And 2 maps to 6, 2, 6. Do we have any repeating x values in these points? No, that means yes, this is a function. Same question on number 5. On the x side, are any of the x's being mapped to more than 1? And the answer is no, which means yes, this is a function. You can tell that the x's don't repeat because there's only one arrow coming out of each x. It's okay that they both go to the same y. It's not okay if they have arrows coming out of the same x. And that actually is a perfect segue into number 6, because we've got 2 arrows coming out of 5. No, we have repeating x values. We would have the points -5, 2, and -5, 10. That is a no-no. Can't do it. It is not a function. Now we have graphs. We do these with the vertical line test. We really are just checking by imagining drawing through with vertical lines. Let's do that now. So we've got nothing over here. The vertical lines don't even matter. Here, the vertical lines hit at 1 point, and then immediately after that, they hit at 2. So, no, it fails the vertical line test. Now we're going to do the same thing on number 8, and we're going to see it doesn't look like it, especially because the graph is so small, but I draw, only hits once. Draw, only hits once. Draw, only hits once. This line is never going vertical, no matter how close to vertical it gets. Every vertical line that I draw is only going to cross this function at 1 point. Yes, I called it a function because it passes the vertical line test. Yes, this is a function. None of those lines were hit more than once by a point from the graph. And one more vertical line test here. We are going to do any line through this thing is going to hit twice. This circle is not a function. It fails the vertical line test. So use either Desmos.com or your graphing calculator to graph number 10. Probably your graphing calculator. We're going to go down 4 for those of us graphing by hand, then up to right 1. And we draw our line, and if we were to draw vertical lines through, we would see it never hits the line more than once. Yes, this is a function. We had to graph it to find out. I've gone ahead and graphed 11 and 12 for you because you don't know how to graph them yet. And so x equals y squared, we're going to test it out. This is actually identical to the one we did earlier. And no. And it fails the vertical line test. And then x equals the square root of y. Vertical line hits once, hits once, hits once. You can see it's only going to hit once. Yes, this is a function. One more function problem. That is the graph of a parabola. And it's appeared like magic. Vertical line test. This is the opposite of the one that equaled y squared. We're only going to hit once every time we do this. Yes, this is a function. Now it's time to talk about domain and range. So before, when we talked about domain and range, it's the x values and the y values of the function. Or in some cases, a relation. Let's check it out. Okay, so for the points, all we're going to do is say x equals the list of x values, and the range is that y equals the list of y values. And I always put them in numerical order. I don't know what Mr. Austin does, but that's what I do. So for the domain, x equals, and it looks like the x's are in order, -5, -3, -1, and 0. Cross those out so I don't get them confused. Y equals, and it looks like 0, 1, 2, 3. And that problem is done. The domain for the next one, handily enough, the x values are in order again, no repeats. -4, -2, 0, and 1. And the range, we do have repeats. We only list them once. In order from smallest to largest would be 1/4, and then 1/2. And that's it. They both repeat, but we don't have to mark that in our range. Okay, so we've got another list of fractions for our domain. From least to greatest, we're going to go -3/4, -2/3. Then it looks like 3/5, 2/3, and 3/4. And then on our y values, our range, -1, 0, and 1, knowing that the zeros and the ones repeat. Okay, and then on the mapping ones, it's so much easier. The x's and the y's are already separated out for us. We're just going to copy down the x's, -7, 1, and 8. For the range, we'll just put them back in order, 4, 6, and 11. That's it. That's all we do for the maps for the domain and range. We will jump to 18 now, and we've got a graph. And so we don't have just a list of points. We've got infinite points. This thing is going to go left forever, and it's going to go right forever. It's going to go up forever. It's going to go down forever. And I'm not sure that we want to write every number for infinity, so we need a new symbol. And that new symbol is this R. I put a double bar here, and then I finish the R over the curve of the two lines. That R means all real numbers. All real numbers. Let's define that real quick. All real numbers. Every number that is real. And yes, there are numbers that are not real. The range, we said this graph with no breaks is going to go up forever and down forever. That means that is also all real numbers. For the next graph, things are much more different. So if I'm tracing the x values, that's the x-axis, this graph starts at 0 and goes right forever. The way we write x's that start at 0 and go right forever is right is greater than things. X is greater than 0, and because it starts at 0, it's also equal to 0. X is greater than or equal to 0. The same thing's going to happen on the y's. We're going to have y's that start at 0 and go up forever. Things that go up forever are also greater than. Y is greater than 0, and it's also equal to 0. Okay, so we're going to end this on two graphs that I have provided for you because, again, we're not testing whether you can graph these yet, so I'm giving you the graph. On number 20, we've got this parabola. For the domain, we know at the end of this we have arrows, right? And these arrows mean that to the left this graph goes on forever, because you can see the arrow skews off to the left. And to the right it goes on forever, and there are no breaks in between on the parabola. And that means that x is every single real number on the x-axis. No breaks. But on the y-axis, we've got a stopping point right here at -3. That means y is greater than or equal to -3. It's all above -3, that's the greater than, but it does have a point at -3, and that's the equal to. Number 21 is a very similar situation. We've got arrows on the ends of the graph. That means we're going left forever and right forever, with no breaks in between. So the domain is all real numbers. And the range is everything from 0 and up. Y is greater than or equal to 0. That was a ton of examples, and if you're still confused, you can go back and check some of those out. I know we ran through it fast, but this video is already 20 minutes. If you have any questions, please message your teacher. There is an assignment on this here in Canvas. Check it out, and I'm sure I will see you soon. Thanks.